Okay, so today we're learning how to solve equations with one variable and two variables. What did we learn last week? What have we learned so far in chapter 1? PEMDAS. Okay, we're going to see PEMDAS in this also. So, we're going to deal with replacement sets, solution sets, solving equations, identities, some stuff we've already talked about. Okay, so on example 1, it wants us to find the solution set for 4a plus 7 equals 23. If the replacement set is 2, 3, 4, 5, and 6. So, what that means, they did this one for us to show us, they're taking all of these, numbers and doing what with them? Substituting in for what? A. They're substituting it in for A here, okay? So in this one, they substituted 2 in. They got 15 equals 23. Is that true or false? That is false, so it didn't work, okay? They did the same thing for 3, and they got false. Same thing for 4. They got true. 5, they got false. 6, they got false. So it wants us to write the solution set. So what was the only solution that worked? 4. 4 was the only solution that worked. So your answer, you write that with little brackets with 4 in the middle. Okay? Every solution that works, you put it in brackets. Okay, but 4 was the only one that worked, so that's all we need to put for that one. Yeah? Okay, so next one, it wants us to find the solution set for 6c minus 5 equals 7 using this replacement set. So, what do we do with the replacement set? What do we do with the replacement set?
Substitute in for C.
Substitute in for C. So, if I put C of 0, I have 6 times 0 minus 5 equals 7. 6 times 0 is 0, right?
Yeah.
And then 0 minus 5? Negative 5. Does negative 5 equal 7? No. So, that one does not work. C of 1... We have 6 times 1 minus 5. What's 6 times 1?
6.
6 minus 5? 1. Does 1 equal 7? No. Then moving on. C of 2. 6 times 2 minus 5 equals 7. What's 6 times 2?
12.
12. What's 12 minus 5?
7.
Does 7 equal 7? Yes. Automatically, do we have to do 3 and 4? No. Why?
Because we already found the answer.
We did already find the answer. Out of all these answer options, can we have any other answer? No. So our answer is just 2. Okay, 2 is the only solution that worked. Okay, and since none of the other answers include 3 or 4, we don't need to do those. Okay? With solution sets and replacement sets. Okay, remember your replacement set you do what with? Substitute it in, and then find all that work, all that apply for that equation to make it true. Okay? How are we feeling? Okay, now we are actually going to solve for these variables. Okay, so what we have here, we already have the variable by itself. That's our main goal, right? To have the variable by itself. W is already by itself, so we just need to solve that left side. Where do we start? There's a lot of numbers over there. Let's just start on the top, okay? What do we need to do on the top first? Parentheses. So we have 3 times, what's 6 plus 4?
10.
10. Okay. On the bottom, what do we need to do first? Subtract what?
10 minus 6.
Okay. So we have 21 minus, what's 10 minus 6? 4 squared. Everyone okay there? Okay. What's 3 times 10? 30. What is 4 squared? Because we got to do exponents first. Good. What's 21 minus 16? It is 5. 30 over 5 is 6. It looks weird over here. 6 is your D, right? On your notes? Good. Our answer is 6. So W equals 6. So all we did there was use PEMDAS to solve for W because W was already by itself. Bless you. Yeah? Okay, moving on. I'm going to skip this slide. So let's just walk through this one. It gave us the original equation here. Okay. And then what was the first thing that it did? Look on the left side. What was the first thing that it did?
Distributed.
Distribute what?
Give me a sec. The 6 and distribute n times 6.
What about on the left side?
On the left side.
Right here. How did they get to this? What's different? What? How?
By turning to subtraction power.
Yep. This negative sign, they treated it as a -1. They distributed that -1 into there to get rid of the parentheses. Okay? On this side, someone already said it. They just distributed that n in, right? So they got this. And then what was the last thing that they did?
Simplify.
Simplify. How'd they do that?
By finding the answer.
What does simplify mean? Combining like terms, okay? They combined like terms on this side, the 12 and the 2, and then this side they combined the 6n and 2n, okay? What that says, can these ever be the same? Will you ever get the same answer there?
Yeah. No.
Why no?
I don't know.
Subtraction? Or because it's...
What's different between both of those sides? What's the same?
4n.
4n, what's different? 14 and 9. So any number I plug into there, because if you put n equals 1, I have to put 1 in for both of those n's. Would I get the same thing if I put 1 in? Or any number? No, because it will always be 5 different. Because 14 and 9 are 5 different. Does that make sense? So those answers would never be the same. So this would have no solution. Correct? So your answer for this one would be no solution. That's if your set was empty. All right, next example, we need to solve for f. What does solve for f mean?
Solve it.
What do you mean, like how?
Find what f is worth.
Find what f is worth. How do we find that?
By figuring out the problem.
What's our main goal?
To find
What's
the
our
answer.
end goal?
To
Find
solve.
F.
To get f by itself, right? That's what I was trying to get to. We want to get f by itself. What's our first step to get f by itself? Get rid of parentheses. Let's do order of operations. What's 42 minus 6?
Yeah, it's close.
4 squared.
Thank you. Thank you. What's 4 squared?
16.
16 minus 6 plus f, you're right, equals 12. So we have 10 plus f minus 9 equals 12. What's next? What do we do now?
Combine like terms.
What can we do before that?
Add 9.
Add.
Okay. Can we do something before that? We want to simplify on both sides first. So I heard it. Let's combine like terms on the left side. 10 minus 9 is... So we get f plus 1 equals 12. Now what can we do? Subtract 1. So f equals 11. 12 minus 1 is 11. Okay. I heard let's just add the 9 over and then add the 9 over. Could you do that?
Yeah.
You could. You would just have to also take the 10 over. Okay. I think it's easier to simplify on both sides first before you start moving things. Okay. So simplify on both sides before you start moving things over. Okay. On this one. Okay, let's see if we have any solution. What do we do first? Start with the left side. Can we do anything with the left side? Look on your paper first, not mine.
Oh,
We can do...
72. 72 is 7 squared.
Thank you. What is 7 squared? 49. Okay, let's just finish out the left side. Okay?
Subtract.
Subtract 2n. What's 49 minus 29? 20. Let's do the left side now. I know I'm running out of room. What's 2 cubed?
8.
8 minus 3 times 2. I know there's an n there. Plus 29. 8 minus 3. Oh, what do we do in the parentheses?
You
You
multiply
multiply the
3
3
and
and 2.
Multiply 3 first. Good. What's 3 times 2? 8 minus 6. So we have 2n plus 29. Is there any like terms on that side? No. So I'm going to bring it down here.
Oh.
Is there going to be any solution? Why? We don't even need to finish, right? How do we know there's not going to be any
Because
solution?
N plus 2n plus 20 and it's 2n plus 20.
Right, so they're never going to be the same. Okay, so our answer would be no solution. What if I had 2n plus 20 equals 2n plus 20?
Yes.
Yes.
How can I put that as an answer? Did I just put solution?
No.
So if this was true,
Real number.
It's 4 over.
okay, close. I want you to put infinitely many solutions. Okay, if that ever happens, I want you to put infinitely many solutions. Does that make sense? So any number you put in for n in that case would be true. Let's go to the next one.